So there are two reactions of group 2 compounds we need to know. Really important, keep these separate from the group 2 metal reactions. So the group 2 compounds, the first one is going to be the metal oxide with water. So number 1 is your metal oxide plus water. And again, we're just going to pick calcium for our example. Very easy. Calcium oxide as a solid plus water liquid gives me calcium hydroxide aqueous. That's a solution of calcium hydroxide. This is a really exothermic reaction. So it's going to get hot. What would you see happening in that reaction? You'd feel it getting hot. What would happen to this solid here if it's becoming a solution? You had what would it would?
Gives off a gas.
Sorry?
Gives off a gas.
There's no gas on it making a solution. I've got a solid and a liquid. What would you see happening to that solid?
Fizzling.
It would dissolve. Yeah, it would disappear. Okay, fine, actually. Yeah, so the solid would disappear. This is only sparingly soluble, so sometimes you still see a bit of a white solid left, which is your calcium hydroxide, because this is only sparingly soluble. It's not very soluble. Not very soluble. What about the pH of this solution? If we measure the pH, where would we be aiming? pH, what do you reckon? Metal hydroxide is going to be a alkali, yeah, so pH is going to be on the high side, yeah, around about 9 or so. I mean, it can get higher. So pH will be around between 9 to 14. Number 2 is the thermal decomposition of the metal carbonate. And let's do calcium carbonate. Calcium carbonate solid would go to calcium oxide as a solid plus carbon dioxide gas. Very tedious reaction. That's a white solid, that's a white solid, that's a colourless gas, so you don't really see much happening. How could you make it more exciting? Well, you could bubble this through lime water, and what would happen to the lime water? Go cloudy, yeah, that would be the test for carbon dioxide, but other than that, quite a tedious reaction to do. Now, what we just made, as you go down the group, go down the group, the metal carbonates get more thermally stable. What does that mean? It means you need a higher temperature to decompose them.
Why do they get more thermally stable?
That's a very good question, and we'll talk about that. Right, so we're going to try and work out why do they get more thermally stable. Okay, we're going to try, you don't need to know this for the exam, but it's quite interesting, you should be able to figure it out. Let's have a think. I'm going to compare magnesium carbonate. So magnesium carbonate is little Mg2 plus ions and the carbonate ion, which we're going to draw like that. We're going to compare that against big boy strontium. Strontium is further down the group, so he is going to be a bigger ion because he's got more shells. So strontium 2+ is going to look like that. Carbon 8 is still the same. What is happening? Well, I am making MgO plus CO2, and here I'll be making SRO plus CO2. What we can say here, he's a lot bigger. They've got the same charge, but he's bigger. So, what have they got to do? That oxygen has to go onto that magnesium, don't they? They've got to attract each other to form MgO. So, those guys have to go off together, and those guys have to go off together. That bond's going to break. Those two are going to go off, and I'm going to be left with CO2. Yeah, like so. So, this guy, little, same charge. So he's got a higher charge density. He's got the charge concentrated over smaller. So he's going to be able to attract that O- more than this guy with the 2+ where the charge is spread over a much larger ion. So that's the reason I don't need such a high temperature to decompose. So this one will decompose at lower temperature because of that. It's all to do with the charge density and the fact that he can capture that oxygen much easier than the strontium can with that
Because
oxygen.
he has more charge.
He's got the same charge, they've got the same charge, but this charge is over a smaller volume. He's really small.
Oh, it's got smaller atomic radius.
Yeah, he's much smaller ion, so he's like a concentrated version of the charge.
Oh, okay.
This guy's got the charge spread over him, so it's like, but it's really concentrated charge, so he can capture.